before we look at the complex numbers, I'd like to just review the number sets that we have in our possession. So the first one that we can talk about is the natural numbers. Okay, the natural numbers, given this symbol n, okay, these are our counting numbers. Okay, so 1, 2, 3, and so on. Okay, it includes 0. Okay, some systems choose not to include 0, but we're going to include 0. So these are the whole numbers, okay, the counting numbers 0, 1, 2, 3, and on up to infinity. Okay, in this number system, there's no such thing as a fraction, there's no such thing as a decimal. Okay, they're all whole numbers, right? So this was the first system really developed by mankind. Okay, if you're counting anything, you would use this system of numbers. Okay, the next system of numbers which was developed are the integers, given this simple symbol z, which comes from the German for integer. Okay, the integers are also whole numbers. Okay, 1, 2, and so on, but they now include negative numbers. -2, -1. Okay, all whole numbers, but including negative ones. And this really arose when you're talking about things like debt. So you owe money to somebody else, so you can talk in terms of negative numbers. Okay, you could also think that they were used to solve equations like x minus 5 equals 0. What would x be? Okay, so x in that case would be equal to -5. Okay, but you can see that the natural numbers are contained within the integers also. Okay, the next number system I'd like to look at is the quotient. Sorry, the rational numbers. Okay, given this symbol q, which comes from quotient, which means essentially the same thing as a ratio or a rational number. Okay, the rational numbers are all the whole numbers, 1, 2, 3, and so on, all the negative whole numbers, -2, 1, all the way to minus infinity and all the way to infinity. But it also includes now fractions, so numbers in between whole numbers. Okay, so the rational numbers might include or might be used to solve equations like this: 2x equals 3. So this can't be a whole number, right? Because x, if you divide both sides by 2, you would get 3 divided by 2, which is not a whole number. Okay, so the rational numbers, they are all of the whole numbers, negative and positive, and fractions. And you can see that the natural numbers and the integers are all contained inside the rational numbers. Okay, and the last number system to be developed before complex numbers was the real numbers. Okay, so this is essentially everything, okay, on the real number line, here on this number line. Okay, it includes the natural numbers, the integers, and the rational numbers. Okay, so all whole numbers, all negative numbers, okay, all fractions, half, and so on. Okay, so you might ask, what other types of numbers could there possibly be, right? But there are such things as irrational numbers. Irrational numbers, that means numbers that cannot be expressed as a fraction. Okay, so you might think of solutions to this equation, for example. X squared is 2. What multiplied by itself gives 2 as the answer? Well, the solution is the square root of 2. Okay, but the square root of 2, it cannot be written as a fraction of some a over some b. This is a famous proof in mathematics. You usually do it in first year of university. Okay, you cannot express root 2 as a fraction. Therefore, it's not a rational number, and it's certainly not an integer or a natural number. So it's some new number. Okay, and when we add irrational numbers to the rational numbers and the integers and the natural numbers, we form the real number system. Okay, so this real number system has every possible point, including, so root 2, for example, root 2 must be between root 1, which is 1, and root 4, which is 2. So it's somewhere between 1 and 2. Okay, so we know that even though we can't express root 2 as a fraction, we know that it must be between 1 and 2. It has to be somewhere here. Okay, it has to be somewhere between 1 and 2 here. Good. So the real numbers captures all numbers, including these, and irrational numbers. Okay? Pi, for example, the famous number pi, 3.14 approximately, that's a decimal that goes on forever. It's also an irrational number, so you cannot express pi as a fraction of two whole numbers. Okay? Pi, I should also say, is a transcendental number, so you cannot get to the number pi using solutions of some algebraic equation. That's an extra complication there. But the point is, and this is the summary of this whole video, the point is that the natural numbers are an element of the integers, which are all an element of the rational numbers, which in turn are an element of the real numbers. So there's a nested hierarchy here. Okay? And when we come on to the complex numbers in the next video, we will see the last addition to this.